Good morning children, welcome back to YouTube learning. So last classes we have been discussing about the concept of energy, is it not? So in that we have studied about work done, then we have learned about some problems in work done, then we have learned about the concept of potential energy. In potential energy, we have derived an expression for potential energy. Potential energy, basically there are two types, gravitational potential energy and elastic potential energy. So, we have derived an expression for potential energy. What is the expression for potential energy? P is equal to mgh. And potential energy basically depends on weight of the body and height at which the body is located from the center of the earth. So, weight of the body is, which is given by the expression mg, and h represents height at which the body is located from the center of the earth. And we have been solving few numerical problems on potential energy. In today's session also we shall solve some problems on potential energy. So some 3 problems we had solved in the earlier class. Next problem we shall take for potential energy. Now see here, I have a problem. A stone of mass 0.1 kg is projected vertically upward by expending 80 joules of energy. How high the stone rises? Oh, let us solve this problem. A stone of mass 0.1 kg is projected vertically upward by expending 80 joules of energy. How high the stone rises? So you are provided with the value of G as 10 meter per second square. Okay. Now look here. What is the mass given for us? The mass of the stone is 0.1 kg. Okay. And what is the potential energy given for us? It is 80 joules of energy. Now G value is given as 10 meter per second square. You have to calculate the height. Right. So this is how you have to write the data. Write down the data. Mass is 0.1 kg. Potential energy is 80 joules. G value is 10 meter per second square. And you have to calculate the height. Now what is the expression for potential energy? Potential energy is equal to mgh. Now that is equal to 0.1 kg multiplied by, potential energy is given as 80 joules, that is equal to mass is 0.1 multiplied by G value is 10 meter per second square multiplied by h. Now h is equal to how much here? 80 joules by 80 by, so 10 into 0.1. 10 into 0.1 or 10 times is 100. 100 means 1, right? 1. That is equal to 80. Therefore, at what height the stone will be? At a height of 80 meters. This is the solution for this problem. Please note down the solution, children. next one more problem we shall take on potential energy. A stone of weight 0.25 kg is projected vertically upward such that it attains a height of 40 meters. Calculate the amount of energy in the stone at the highest point. Okay. Now, what we are given, see, 1 kg take 1 kg is equal to 10 Newton. Okay. Now, once again, I will read the problem for you. A stone of weight 0.25 kg is projected vertically upward. So, a stone is projected upwards. And what is the weight of the stone? Weight is equal to mg is equal to 0.25 kg. Right? Okay. It attains a height of 40 meters. So, at what height the stone will be? Finally, 40 meters. We have to calculate the amount of energy in the stone at the highest point. So, at 40 meters, what is the energy stored in the stone must be calculated. Now, we have given 1 kg is equal to 10 meters. Now, solution. What is the weight? Weight is equal to mg is equal to 0.25 kg. That is equal to, now he has given 1 kg is equal to 10 Newton. Right? So 0.25 kg will be equal to how much? 0.25 into 10. 25 10 times will be 250. 250 means 25 Newton. Let's cross multiply. So it will be 25 Newton. Then what he has given height is equal to 40 meter. So potential energy is equal to mgx is equal to mg value is given for us 25 into 40. 25 into 40. No, it will be 2.5. Is it not? 25, 0.25 into 10. 250 into 10 will be 25 into 10 will be 250. Sorry, it will be 2.5 Newton, not 25 Newton. So 2.5 Newton. Here I should take 2.5 into 40. How much it will be? 25 4 times will be 100. 100 joules. Therefore, potential energy of the body of the stone at a height 40 meters will be equal to 100 joules. Okay. Please note the solution, children. So remember, on what factors potential energy will depend? Potential energy depends on the weight of the body and also height at which the body is located from the center of the earth. Okay. And always while you are solving the problems, take care to write the correct units, and conversions also must be done. Here the weight is given in kgf. Kgf is the gravitational units of weight. You have to convert it into standard units, that is Newton. So 1 kgf is equal to 10 Newton. That is the conversion. 0.25 kgf will be equal to 2.5 Newton. Copy the solution. Okay, these are some of the problems on potential energy. Now we shall go to the next type of mechanical energy, that is kinetic energy. So potential energy is the energy stored in the body, right? Now coming to kinetic energy. The energy possessed by a body energy possessed by a body by virtue of its motion is called kinetic energy. The energy possessed by a body by virtue of its motion. So any moving body will possess kinetic energy. Now examples you see. A speeding car. A speeding car. Then flowing water. Flowing water. Blowing wind. All these are examples of kinetic energy. Now whenever a body is at rest, energy will be stored in the body. That energy is called potential energy. Now when the body starts moving, then potential energy stored in the body will convert to kinetic energy. Suppose you see water stored in a dam, it will have just potential energy because that water is at rest. But when that water starts flowing, then what happens? Potential energy slowly changes to kinetic energy. So here you can see the interconversion of energy. Any body which is at rest will have potential energy. The same body when it starts moving, it will have kinetic energy. So this is the definition and few examples. You can refer the textbook also for few more definitions. Please note the definition and examples. See, a shooting arrow has kinetic energy. An arrow which is shot, that also will have kinetic energy. A stone rolling down a hill. So, the hill is there and the stone is rolling down. Then what type of energy the stone will possess? It will possess kinetic energy. Okay. Now let us go for the mathematical expression of kinetic energy. Mathematical expression of kinetic energy. Now, kinetic energy mainly depends on two factors. Which are those two factors? One is the mass of the body, and it is denoted by the letter m. Mass of the moving body. Second factor is the speed at which the body moves. The speed at which the body moves. That is denoted by the letter small v. Now, speed here, instead of taking s, I have taken v. Why? Because speed in a particular direction becomes velocity only. So, either you can tell it as speed or velocity. If you are considering a body traveling in a particular direction with a particular speed, then we call that speed as velocity, because velocity has some direction along with the magnitude. Now kinetic energy mainly depends on two factors. What is the first factor? It is mass of the body, and the second factor will be the speed at which the body moves. Therefore, kinetic energy will be equal to half mv square. Now, here in this formula you can observe I have written constant, that is half. Of course, you don't have derivation of this kinetic energy. As you go to higher classes, you will be learning how we arrive at this expression of kinetic energy. Now, for now, you just remember kinetic energy depends on mass of the body and velocity. In the formula, you can see I have written v square. V square means square of the velocity of the body. So, product of mass of the body and square of the velocity multiplied by half. Therefore, half mv square will be the formula or mathematical expression for kinetic energy. Now, coming to standard units, SI unit of kinetic energy, again it will be joules only, because kinetic energy is nothing but energy. So, this is about kinetic energy in brief, definition and mathematical expression. In the next video, we shall try to work out some problems on kinetic energy also. Thank you, children.